topic is polynomials. So first of all, we will know about what are polynomials. Polynomial is any expression that is algebraic expression with variables and constants. For example, I am taking 2x plus 3y plus 5. Now this is a polynomial where these unknown x and y, these are the variables. These are my constant numbers. So the expression which is a combination of the variables and these constant numbers, these digits, is a polynomial. Now in this expression, there are different terms related to it. They are, first of all, a term, coefficient and a constant term. Now this question, this is my question, 2x plus 3y plus 5. Now this is a polynomial. And here first is terms. Terms are these, 2x, 3y and 5. These are my three different terms in this polynomial. That is combined with the help of plus and minus. Okay. Now the other is coefficients. Coefficients are the numbers which are with the signs multiplication or division. If I see here, it is 2 into x. So my coefficient of x is 2. 3 into y. The coefficient of y is 3. And my 5, this 5 is a constant term. That is my, this one. So 5 is my constant term. Now it is very important to remember the coefficients are what? Like 2x. 2x. Then 2 is coefficient of x. If I am talking about 3y, then 3 is the coefficient of y. So it is by the sign multiplication and division, and term is by the sign plus and subtraction. Now the next important fact related to polynomial is the degree of a polynomial. So first of all, the polynomial can be in many variables, like in one variable, in two variable, in three variable, but we are mainly focusing on just one variable. And also in one variable there can be degree of a polynomial. What is a degree? For example, if I take 2x plus 3, now we will see the power of the variable. Degree is power of variable. And it is the highest power of the variable. Like if in 2x plus 1, if I see this variable x, it has the power 1 over here. So the degree of the polynomial will be 1. Now if I have, taking another example, it's like x squared plus 3x plus 2. Okay, this is a polynomial. Now this is a polynomial in one variable because there is one variable x. And what is the degree? We will look at the highest power of the variable. Here the power of x is 1 and here the power of x is 2. So the highest is 2. So my degree will be 2. Now there are two special cases when the powers are not defined. Okay, now the first one is the rules you need to remember that power can never be negative or in fractions. If ever a polynomial has a negative power or a fractional power, then that expression is not a polynomial. The polynomial should have a power that is a positive number, like that is, you can say, a natural number. Natural number power can be there, but the powers cannot be negative or in a fraction. For example, if I take x plus 1 by x. Now this is a question and we need to classify it as whether it is a polynomial or it is not a polynomial. So looking at it, the x is x, but we know the rules of exponents. that whenever something is in denominator, I can bring it to the numerator by the negative powers. So this x will be x raised to the power minus 1. And if an expression has the negative power, then no, it is not a polynomial. This is not a polynomial. Okay. Now another example, if I take root t plus t square. Now what is this root? I know that by exponents root is written as power 1 by 2. It is my t raised to the power 1 by 2 plus t square. And again, if the power is in fraction, like I have said that the power can never be negative or in fraction. So t raised to the power of fraction. So it is also not a polynomial. Now there is one more thing. Students actually get confused with it. It has root 2x plus x square. Okay. So here I can see that 2 has the power negative in fraction. But x doesn't have the fractional power. X has 1 and 2 as powers. So this expression is a polynomial. So don't confuse this root by this root. This is the fractional power of the variable. And this is a constant. That is just a coefficient of x. Till now we have learned about the definition of term and degree. Now we are going to know about the types of polynomial. Now the polynomials are divided into two categories based on terms and the basis of degree. Now first coming to the terms. This is a flow chart of the type of polynomial. Now first of all, on the basis of terms. The first one is monomial, then binomial, third trinomial, and all the others are called polynomials. Now what is monomial? Monomial is any polynomial or any expression which has only one term. If I take example of this, it can be like x. For example, it can be x or 2x square or 9y cube or anything. Just one term in the whole expression. Now binomial. Bi itself means 2. So it has 2 terms. So 2 terms can be like x square plus 2 or x cube plus 4x. So any expression of having 2 terms. Now trinomial. Tri itself means 3. So it has 3 terms. For example, x square plus 3x plus 2 or x4 plus 2x plus 9. These are the example of trinomial. Now on the basis of degree. Now degree is what? The highest power of the variable. Now linear equation is the equation or linear polynomial is the polynomial which has degree 1. It has one term, it has degree 1. We don't know about how many terms it will have. It can have any number of terms, but degree should be 1. Like I can say as x plus 2. Now I can see that the power of x is 1 here. So it is an example of linear polynomial. Now second is quadratic. Quadratic means degree 2. So it will be like x square plus 2x and that's it. Or I can also add 3 over here. I am not focusing on how many terms it has. It can have 2 terms or it can have 3 terms or it can be simply x square. I am not focusing on the number of terms. I am only focusing on the power of x. The x power is 2 for quadratic. Now third is a cubic polynomial. Cubic is power 3. So I can write it as x cube only or x cube plus 2x or 4x cube plus 9x square. So these are cubic polynomials. Now the fourth one is biquadratic. Biquadratic is bi means 2 and quadratic I have already told you that it's 2. So 2 into 2, that is 4. So it is the power 4. X to the power 4 plus 3x square plus 9. This is a biquadratic polynomial because it has degree 4. But if I write this in the form of terms, then it is a trinomial. So it is a trinomial of degree 4. It is a biquadratic trinomial. Okay. Now coming to the very important topics related to polynomial. The first one is value of a polynomial. In these type of question, we are given a polynomial. Suppose we are given a polynomial px. This is how we denote a polynomial. It can be fx, ax, bx, anything, but in general form we write it as px. Now suppose we are given a polynomial x cube plus 2x square plus 3. Okay. Now we are given the question that find the value of a polynomial at x equals to minus 1. Okay. Now this is my question. Value of a polynomial. How to find the value of polynomial is just putting the value given to you in this polynomial. So my answer will be p minus 1. That is, whenever you see an x in the question, put minus 1 there. So I will write minus 1 in this px also. P minus 1, it will be my minus 1 cube plus 2 minus 1 square plus 3. Now I will solve it. Minus 1 cube, that is 3 power, it will give me minus 1 plus 2 into minus 1 square, minus into minus, it will be plus. So it will be my 1 plus 3. So minus 1 plus 2 plus 3. It will be my minus 1 plus 5, that is 4. So this is how we find the value of a polynomial at a particular point. Okay. Now the next topic is 0 of a polynomial. 0 of a polynomial is that value of x which gives me the answer 0. For example, I am given a polynomial px as 2x minus 4. Okay, this is a polynomial given to us. We need to find the value of x where the polynomial gives the value 0. That means what value of x I will put in this question, so my answer becomes 0. So by hit and trial method, if I think in my mind, I can easily see that if I put x equals to 2, my answer will be 0. But in mathematics, we need to show everything. So what I am going to do is, I am going to put 2x minus 4 equals to 0. Whenever I need to find the value of x, then I am going to put it equals to 0. So I will transpose this 4 on this side, it will become plus 4, and then it will become 4 divided by 2, that is my 2. So my value of x will be 2. So you can see that this is the value of polynomial, this is value of x, or you can say 0 of a polynomial. So in some places this 0 is also written as root of polynomial. So whenever it says find the root of polynomial or it says find the zeros of polynomial, they are saying the same thing, that you have to put it equals to 0 and find the value of x. Now let's do some example based on the concepts we learned till now. Now this is my example number 1. The question 1 says that tell us whether it's a polynomial or not. Okay, polynomial or not. This is what you need to tell in this question. So I have told you that when it's not a polynomial, when the power is negative or power is in fraction. So I can, and in these type of questions they always say justify or give reason. So in the first question I can see that the powers are positive for the variable. Here the power is 2 and here 1, so both the positive power. So we will just write yes, it is a polynomial, and why? It asks for the reasons also. So why? Because all the powers are positive. Now second part is t root 2 plus 3 root t. Okay, this is my question. Now I can write it as 3 t to the power 1 Now I can see that power is in fraction, right? So my answer will be no, and the reason is because power is in fraction. Reason is this? Yes, because power is positive. Okay. Now my question number 2 is write the degree of the polynomial. So we will see that the highest power of x, here we don't have x, here x to the power 2 and here x is the power of 3. Now I know 3 is greater than 2, so my degree will be 3. Now similarly in this question, first of all always check whether it's a polynomial or not. This question is a polynomial because this root is over 2, not over x. So root 2 is just a coefficient and x is my variable and x has the degree 1. So it has the degree 1. Now coming to my question number 3. Classify as linear, quadratic and cubic. Similarly the question can be asked classify as monomial, binomial or trinomial. Now we are doing the linear, quadratic and cubic. Always remember linear, quadratic, cubic we will see the degree. For monomial, binomial, trinomial we will see the number of terms. So here we will see the degree. We can see that degree is 3. So it is a cubic polynomial. Okay. Now in this question we are given this question and some students do what? They see that the highest power is 2, so it is a quadratic equation. But for doing this, we need to solve it first. If I see properly, then these x square and this x square is getting cancelled. So I will left, and this 4x and 2x is getting added. So my polynomial is 6x minus 2, and this is a linear polynomial. Okay, so always first simplify the equation and then try to find the question. For example, if I have another question like this, x cube plus 4x bracket x cube plus 2. Now we need to tell it linear, quadratic or cubic. So first of all we will open this bracket. So it will be x cube plus 4x minus x cube minus 2. And this x cube will cancel out. Again, this is a linear polynomial. Similarly, for binomial, trinomial also need to simplify it. Okay. Now, this is my example number 4. Px is given to be x minus 1, x plus 1 and we need to find p0 and p2. p0 and p2 denotes that we need to find the value of polynomial at x equals to 0 and x equals to 2. So we are going to just put 0 and 2 in place of x. So for p0, I will have 0 minus 1, 0 plus 1. So it will be minus 1 into 1, that is minus 1. Similarly for p2, I am going to put 2 in place of x and it will become my 1 into 3, that is 3. Now coming to question number 5, it says find zeros. So I have told you that while finding zeros, we just need to put the given question equals to 0. So I will put 3x minus 2 equals to 0 and 3x will be equals to 2 and my x will be equals to 2 upon 3. Right? Now similarly in this question we will put px equals to 0, that is ax equals to 0. In this question it is given that a is not equals to 0. If a is not equals to 0 then obviously x have to be 0, so my x equals to 0. So now we will be starting our next topic, that is remainder theorem. Now first of all, what is a remainder theorem? In remainder theorem it says that whenever we are given a polynomial, say px, and it is divided by x plus a or x minus a or any number, suppose it is divided by x minus a, then the remainder is nothing but p divided by some polynomial x minus a, then my remainder is p at a. That is, if I put my x minus a equals to 0, I will get x equals to a, and then I will put this a in my polynomial and I will get the remainder. So earlier we used to properly divide the polynomial to find the remainder. Now we have a shortcut method to do that. That is our remainder theorem. Now let's do an example. This is my example. That x cube plus 3x square plus 3x plus 1 is divided by x plus 1, and we need to find the remainder. So the first method is properly dividing, or you can directly use the remainder theorem. I am going to do both methods. So first of all, I am going to divide it. So x cube plus 3x square plus 3x plus 1 is divided by x plus 1. Okay. Now I will take x square, change signs, it will be 2x square plus 3x plus 1. Now I need 2x square here, so I will add 2x. So 2x square plus 2x. Again changing sign, x plus 1. So I will add 1 here and it will be x plus 1 and it will be 0. So my remainder is 0. Now I can also do this question by remainder theorem. What I am going to do is put x plus 1 equals to 0. So my x is equals to minus 1. Right? If this is my px, I am going to find p of minus 1. That is minus 1 cube plus 3 minus 1 square plus 3 minus 1 plus 1. Right? I just put the value minus 1 in this polynomial. So I will get minus 1 plus 3 minus 3 plus 1, and my answer is 0. So no matter by what method we do it, we will get the same remainder. So in this chapter, we are actually given question by saying that find the remainder if this is divided by this. So it's up to your choice which method you are doing, but it's more good to use this method. It is better to do this method because there is less scope of mistakes. It can be very lengthy and it can have many mistakes also. So this method is quite applicable and this method is you should use. In this video, we are learning about remainder theorem and how it saves our time. Instead of actually dividing a polynomial, we are just putting the value of x and I get the remainder. But whenever the question says that find the quotient and remainder, then in that case you need to divide it, and if it says find the remainder, you just need to put the value. But there is one more question which can be asked on remainder theorem, that is find whether it's a factor or not. Now first of all, what is a factor? Factor is any quantity, or you can say a number, or in the case of polynomial you can say a polynomial which will perfectly divide the other polynomial. If I say I have 60, okay, I can make the factors of it. Like 60 is my, if I divide it by 2, 30, 2, 15, 3, 5, 5, 1. So 60 is my 2 into 2 into 3 into 5. So this 2, 3, 5, these are the factors of 60. Also I can say 2, 3, 5 or 4 or 10 or 6 or 30, 20, 60, 15. These all are my factors of 60 because all these numbers perfectly divide this 60. Similarly for the polynomials also we can find whether it's a factor or not. How? If the remainder is 0. That is, I am saying that it perfectly divides the polynomial, so my remainder should be 0. So if my remainder is 0, then it is a factor. For example, if my question is x square plus 2x plus 1 is divided by x plus x minus 1. Okay. This question is, this is divided by x minus 1 and we need to find that whether x minus 1 is a factor of this or not. So first method we can divide it. If remainder is not 0, then it's not a factor, but we know the remainder theorem also. So put x minus 1 equals to 0, my x will be 1. If I put 1 in this, my p1 will be 1 square plus 2 into 1 plus 1. It is 1 plus 2 plus 1, it is my 4. So remainder is 4. Remainder is not equals to 0. So it means that this polynomial is not a factor of the polynomial. So we will write not a factor. Okay. I hope you like the video. Thank you.